Hey, what's up, guys? How you doing? All right. Cool. All right, so we are on to class number 6. I changed some configurations, so please let me know in the chat if the volume levels are a little bit off. Everything should be okay, though, but do let me know. All right, so we're going to work through if-else statements, switch statements, and then we're going to do an introduction to for loops. We'll probably do some more complex things with for loops in the next lecture or so. But this is going to just kind of end with that. So anyway, without further ado, here we go. Sweet. Hey, hey. How's it going? All right. Cool. So we're going to be on to class 6. Sweet. All right. Hey, first thing I want to talk about is input. We've already seen output through system.out, right? We've used system.out to print a line. And what we've effectively done when we've used that particular function, we've actually tapped into the system output through sending just an arbitrary string through. And what that allowed us to do was to output text to the terminal. So now we're going to try getting input from the terminal. Okay, so it's been a while since I've done this, so bear with me. It's pretty simple stuff. A second here. Whoops, lost my place. All right, there we go. Okay, so let's go over to our Blackboard, right? And let's talk a little bit about how exactly we're going to do that. Okay, so similar to system.out.println, which prints text to the output stream, right? We can do something else. We want to get input from the user, okay? So we're going to use basically the same general idea, system.in this time, right? And then there's a special function that we can call called read, okay? This reads a single character from the keyboard, okay? Baby steps, right, guys? Okay, so this is entirely opposite of the system out stream, okay? So I do want you to know a couple things. One, it's a single character. Two, it only returns an integer value, the ASCII code of that character. It doesn't actually return the character, so you have to convert it to the character itself. And that's because, you know, when you take your keyboard maps to a bunch of integers for the ASCII characters, and that's what it's returning, right? There's nothing special about this thing. It's literally just read the integer value of the key you pressed and report that back to whoever called the function. So you have to do a little tiny extra work, but not a lot, okay? So let's go over here to this keyboard input, right? Okay, so we're gonna read a character from the keyboard, okay? So there's a couple things. We know that we want to capture character from the keyboard, right? So let's create a char, and let's call it input, right? So that's going to be our input that we're going to store our value, right? So when this program runs, I want it to ask the user for input, right? So the first thing we want to do is we want to print a message to the screen saying, please enter some input, right? So we're going to use our standard system out, print line, and so press a key, then press enter, okay? So that'll direct the user to do exactly what we want them to do. Now, read will finish when you hit the enter key, right? So you press a key, you hit enter. Cool. All right. So we know that we can do system.in.read. Okay. And this, oh, come on. This gets a char, right? But we also know that we want to catch it in the input that we created, right? So char input equals that. But we know that it returns an integer. So what did we do in the last lecture, or maybe it was the one before, where we converted one value type to another? Well, in this case, we want to convert it to a char, right? So before we do anything else, I'm going to go over to my Blackboard here, and I'm going to say note returns an integer, must cast to a char after the function call. Okay, so just put that note there for later. Okay, so now that we've captured the input, now let's go ahead and let's print that out, right? I'm gonna say your key is cool, except it's not that. It's input, right? Okay, looks good. So let's go over to our terminal, and we're gonna compile that. It's keyboard input. Yeah, that's it. Okay. Oh, what is that? Variable input is already defined. Ah, right, because we have to do this. There we go. Cool. Let's compile that again. Ooh, what is this? This is new. Unreported exception, IO exception, must be caught or declared to be thrown. Okay, so during our first lecture, I briefly went over this and I said this is going to come back later. This is one of those times. We're not going to go into a lot of extensive details on this, but what I will tell you is that in Java, if you call a method that is declared to throw an exception when there's a problem, then you have to handle it, or you have to mark your method to handle it as well. So in this case, we don't want to write code to actually handle that exception because we don't really care, right? This is in production ready code, you would. This is an example. So this thing can return an exception, but we don't handle it, right? So there's nothing that says try to run this code, and if there's an exception, we catch it and we do something with it. We didn't do that. So it knows, and it says you must mark your method accordingly. So up here where we have declared our method public static void main, the thing we have to do here is we have to say that it throws, right? And it's an IO exception. Okay. Now I will tell you right now that the exceptions for this particular package are in the java.io package. Whoops. And I'll show you how you can find that out, right? So I'm going to copy that. I'm going to go over here to my Google window. I'm going to type in IO exception Java. And the first thing that pops up is, yeah, let's go with the first one. Sure, why not? Cool. So there it is. That's how you tell. So that's what you'll have to use. Now, you can also do something like this. You could import java.io exception. And what that says is I want this particular object from this package. So I don't have to actually prepend it with this. I can just say IO exception. Okay? We'll get into imports a little more later. So let's clear the screen. Let's compile it. And there we go. Cool. Let's run that again. Okay, press a key. I'll press W. Press enter. The key is W. Awesome. Point proven. Okay. Cool. That's pretty much character input. So if you ever need to do anything, like maybe press a key to quit an application, what you could do is you could like wait for the user to type a character, and if they do, then you exit the app, right? So there's some nice things you can use that for, but we won't be talking about that too much now. Just be aware that that exists, okay? Cool. All right. So now I want to go over if statements. Okay. Let's go back to our Blackboard. Type this out. Okay. So these are if-else statements, okay? So I'm going to type out the general structure of an if statement here. So the simplified version is if condition statement, right? And then you can say else statement, right? Except that's not going to have, it's just going to be like that, right? Now, if you have multiple statements, now a statement is a single line, right? A bunch of code with a semicolon, right? That's a line. That's a statement. So if you have multiples, you have to put them in between curly braces. So I would always advocate that you always use curly braces, okay? Because code changes and it might get larger. It's nice to just have those there for the next guy. So I would advocate that you want to do something similar to this, right? So I'm going to say statement sequence to suggest that there's more than one, right? And then I'm going to say else statement sequence. Cool? All right. Okay. So this condition right here, and I'll put this here. So a condition must evaluate to a Boolean, true or false, right? That's the only thing that can be in there is a true or false statement, okay? So let's go ahead and let's go over another example, okay? So we're going to do a guess the letter game, okay? All right. So this one is also going to use the system.in.read. So again, we're going to have to say that this throws a Java IO exception. So let's just add that in there. I'm not going to bother to do the import. Oh, you know what? I will. Better to get in the habit of doing this stuff. It's a little bit more typing, but you'll get faster at it as you go. See, that was fast, wasn't it? Cool. So I'm going to define my input, and then I'm also going to define another character that is actually the answer to what I want. So I'm going to say the answer is actually uppercase K. Okay. And I'm going to ask the user to think of a letter between A and C, right? And then I'm going to ask them to guess it. I'm going to read the character, and then I'm going to check to see if what they typed is what I have hard-coded here as the answer. Okay? So that'll show you a simple if check. So system, print line. Let's put it in. Let's see. I'm thinking of a letter between A and C. Okay, so system.in.read. Okay, so let's say that's our input, but we also have to cast it, right? Because it's an integer. The read function gives you an integer, so you have to cast that to a character. You catch it in the input character here, right? And here's the meat and potatoes. So if the input is equal, remember, that's the equals, compares two things together. If the input equals the answer, meaning if what was entered by the user equals the answer k, right, then we're going to print this line. We're going to system out print line. Cool. Does that make sense? So we're getting some input. We're going to compare it to this answer, and if it was the same one, we should get it to print right. So, cool. Okay. So let's run. Is it guess game 1? Yeah. All right. So we compile that. Oh, right. I did that this last time. Okay. Cool. So let's put in E. It says your key is E. That's interesting. Oh, because I ran keyboard input. I want to run guess game 1. Okay, let's run that. So if I guess E, I shouldn't see anything, right? Nothing. Now, if I check uppercase K, there we go. So that's your if check, right? Cool. All right. So now I want to go over, run another example, but we're going to do another version where we actually do an else statement. So basically when it fails, okay? And to do that, there's a couple things. So first, I need this again. I need the throws IO. Well, first let's grab this import. So let's add that there, right? Let's grab this throws IO exception. And let's add that there. And most of the code is going to be the same, right? So I'm going to copy all of that, throw it in there like that, okay? So all I'm really going to do is this. Now, some people, just want to clarify something. Some people will do their curly braces like this, right? I used to do this. I don't do it anymore. It became much easier for me to see how everything is going if I just did it this way. And you get less lines of code. You have to sift through much less stuff, and you do get used to reading this notation, especially since it's already color-coded. Cool. So all we're really going to do here is we're going to add another statement here, right? So I'm going to say, sorry, you're wrong. Try again. Okay? So we're going to compile that one. Okay? Oh. Okay? Let's run that. So if we choose K, it's right. Same as last time. However, this time if we hit E, whoops. Cool. So now you've seen a basic if check. Now you've seen an if else. Okay? Now, let's see here. I want to show you nested if checks. Nested if checks. So let's go back over to the blackboard here. So we do a nested if statement. Okay, so let's copy a few lines here. So let's just say that I'm checking if I equals 10. Okay, so I can actually do another if check here, right? I can say, well, okay, if j is less than 20, right? Then I can actually say, this is where it gets kind of ridiculous, A equals B. But this, there might actually be not an if-else, but two if-checks in a row, right? And I could say, oh, okay, well, if K is greater than 100. Now, all these statements are completely arbitrary. They mean absolutely nothing in the context of anything. This is just an example. I'll clean this up in a second. We're going to say C equals D, right? But this one, let's just say that we want to actually give this one an if-else, right? So we're going to say this one could be A equals C, all right? And then at the very end of this, you could actually do something like A equals D. Whoops. Cool. So that's pretty complex, and we're going to do an example here in a second. But as you can see, anything can go inside the curly braces of an if check, which could be more if checks or more complex code. There could be thousands of lines of code within this if check. That's essentially how coding works. So it can be as complex as you want. So you can nest these things as deep as you want. All right. So let's check out this other example here. All right. So I'm going to base this off of the last one, okay? That's not the right file. There it is. All right, so once again, we're going to grab the Java IO exception. All right, we're going to make sure that the class actually throws that exception. Okay. We know we're going to have this much, right? So we're still going to grab an input, and we're going to hard code our letter of K of our answer. I do still want, let's see, I think I want most of this. So let's just straight copy, and let's figure it out. Yeah, I want to leave that. So we basically duplicated the other one, but now I want to do an if-else over here. But it's going to be inside this else clause here, right? So I'm going to say that if the input if it was less than, let's see, if the input is less than the answer, right, then we want to print that it's too low, right? And then we'll just do an else on there that says too high. Well, actually, no. We can't do that because that'll always happen. So what we'll do is we'll do another one that says if input is greater than answer, right? Cool. So let's run that one. Okay. So first we're going to show that it works. I'm going to type K. Cool. Got it right. Now let's run it. Let's pick something lower than K. Let's pick G. Sorry, you're wrong, too low. Okay. Let's run it again. Let's pick W. Sorry, you're wrong, too high. Cool. So as you can see, you can nest that if statement within the wrong area, right? The part where it actually prints out that you're wrong. All right. Now, let's talk about if-else. So, I'll grab this. I should have been doing this in the first place. Let's just grab this. That didn't work. That did. Cool. So, if-else if statements. So, I'm going to copy this right? Where was our original one here? Copy this and put that there. And what I am going to say is it literally looks like this. Else if condition statement. And you can have as many of those as you want. Okay? But actually, we're going to do ... And then we're going to say the final is like a catch-all. So if every single one of these fails, then we say else. Okay? Okay, cool. So now I want to show you how that works. So I've got this example over here called the IfElse if ladder. Right? So basically I'm going to jump ahead and I'm going to use what's called a for loop. And you've seen this already in lecture 1. We'll go over in a little bit more detail as we catch up to it at the end of this lecture. But I'm going to start with an integer, and I'm going to count up through the iterations of the for loop. And each time the for loop runs, every time it loops, it's going to be running an if check ladder on that number every time. And each time it's going to print something different because the number's always changing. So it's going to show all the different triggers of the different if else statements. So let's define our integer x. Okay. Let's make a for loop, and we're going to say x equals 0. We're going to say we'll go from x to 5. So it'll stop when it gets to 6. And then we're going to do x plus plus to make sure it keeps going upwards, right? So there's our braces. So we're going to say if x equals 1, right, then we're going to print out x is 1. Okay. Then we're going to do an else if, right? And then we're going to say else if, otherwise, basically saying otherwise if it equals 2, right? Then x is 2, right? So let's do it again. We'll say if x equals 3. Right? We're going to do that one more time for 4. And the last one is, so we know that the loop ends on 5. So if it's not one of these, then otherwise, we're going to say x is not between 1 and 4, right? Because we've already caught 1 through 4 here, so this should print. Okay, let's give that a run. And I expect to see this print, followed by this, followed by this, followed by this, followed by this, followed by this at the last hit. Okay. So, yeah, that's it. There we go. And I had a typo, but x is not between 1 and 4. 1, 2, 3, 4, between 1 and 4. Okay. So type that. All right, cool. That's an if statement. That's an if. That's an if else. That's an if else if. That's an if else if followed by an else. So that's basically everything you need to know about if statements. Anything that results in a Boolean value can fit between here. Okay. All right, now let's go to switch statements. Let's go back to the blackboard again. All right, so let's grab some more dividers. Okay. Switch statements. All right, sweet. So this looks like this. You're going to say switch, and then you're going to have an expression, right? And we'll show what that looks like. But inside the switch, and I'm going to put this way down here so I got rim. But inside the curly braces, you're going to say case constant 1, right? And then you're going to say statement sequence, right? And then you're going to say break. And we'll go into what break means a lot later, but there's a lot of uses for break. So we'll say constant 2. Oh, I can't type at all. Okay, so this will be the last one that I add. It's getting redundant here. All right, so I'm going to do that to show that you can have a bunch, right? But then there's a final one called default, and there is no expression. It just does a bunch of stuff, right? And you don't need a break because that's the last thing, right? So after it does this code, it's going to exit out. What does a break do? Okay, so, well, let's talk about the whole thing. Basically, we say, okay, I've got an expression, okay, some expression, not a Boolean, expression, and it evaluates to a value. And what I say is, if it's this value, execute this code, which could be a bunch of statements, and then break tells it to exit the end of this curly brace. If this doesn't match, then it checks this one. If not, it checks this one. If it goes through all of these, right? And I should also say that if this break isn't here, then we will actually execute others down here. So if this were to actually match the expression too, because that could happen, you could have multiple cases that match the expression, then you fall through this one, and it could hit this one and evaluate to true, and it could execute this too. This break is the only way that you have to stop the flow of the switch statement. So make sure you use break unless you know you want multiple of these to be hit. Okay? But provided that none of these actually get activated, it will ultimately make its way all the way down to the default statement, and this will be sort of like your default case. So your default logic. Okay? Cool. So I do want to say that prior to Java, the Java SDK version, JDK 7, expressions were supposed to be, for switch statements, were supposed to be in either byte, short, int, or characters, or possibly in enumeration. But now it can also be string, so it's pretty much a catch-all for most primitive types. So, not much to worry about. All right, cool. So we're going to go and check out this switch demo. Okay, so we're going to demonstrate the switch statement. All right. So we're going to use an integer to be our expression. So let's go ahead and create an int. Right. And once again, I'm going to use a for loop to count up on the integer and show you that as it changes, different parts of the switch statement will become activated. Okay. So do it again. We're going to, okay, I equals 0. I is less than 10. I plus plus. Awesome. And then we're going to do our switch statement. Now remember our expression, we put I in there. Right? I is a value. It could be anywhere from 0 through 9 based off of this loop. And then we're going to say, okay, cool. Case, and my condition, is that what we called it? No, constant. Okay, cool. So our constant is, first is going to be, we're going to do a 0 case, right? And then we're going to say, okay, system out, print line, and then say I is 0. And then we're going to do a break. Okay? I'm going to copy this because this is going to get stupid redundant really quick. What did I do wrong here? That's fine. Okay, cool. I'm only going to go up to 4, so let's see, 0, 1, 2, 3, 4, and then I'm going to do my default case, right? So let's go ahead and update these. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and then let's grab this, and let's say I is 5 or more. Yep, cool. So let's run that. Now let's talk about actually what it should do first. So the first time it runs, it'll hit this, 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 and then this one will print between values 5, 6, 7, 8, and 9. So I should see this 5 times. Cool. So let's run that. What's the name of it? Switch demo. Whoops. What'd I do? Oh, I need that, 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 and that. I'll clear the screen. Let's run that again. Sweet. Let's run it. 0, 1, 2, 3, 4, and then prints this 5 times. Cool. All right. So there's your basic switch statement. Okay. Okay. Now, what happens if you don't use break statements? Now, that can be a pain, right? So, what we're going to do is copy this whole thing. And we're going to go over here. We're going to print this, or sorry, copy this, paste this in here. And what we're really going to do is, so we're going to change this to be less than 5, right? We're going to get rid of the default check. And because we want to see some spacing between everything, I'm just going to print a blank line here. But what I'm really going to do here is I'm going to get rid of all these breaks. Okay? Okay? Now, I'm going to tell you what this is going to do. First time it runs 0. It's going to hit this. It's going to print this. That's it, because it fails these. Second time, it's going to be 1. So, it's not going to print. Let me see. Well, let's just run it. My brain's fried. Switch statement, no break. Pretty sure it's going to print 1 through 4. I guess it doesn't. 0, 1, 2, 3, 4. That is interesting. I would not expect that to happen. Because if I is, oh, that's right. Okay, so this is what it does. So essentially, it checks for the first expression it matches, and then it cascades running everything below it. So once it evaluates to this expression, it prints this. It doesn't care about these other expressions. It's just going to go ahead and rip through all these. When I is 1, it fails this one, and then it passes this one, and it rips through all of these. That's why you see 0 through 4, then 1 through 4, then 2 through 4, then 3 through 4, then 4. Which is what we saw. 0 through 4, 1 through 4, 2 through 4, 3 through 4, and then 4. Again, very rarely do I ever see breaks not used. Generally, what you do is, and I'll show you this right now, like generally what you do is something like this. where you list all the cases you care about and then what you want to happen, right? And then you do a break, right? That's generally what I see. This is dangerous. This leads to bugs. So just be aware that that's a thing that happens, and don't do that. Yeah, at least I wouldn't anyway. All right. Cool. Let's see. Okay, nested switch statements. I'm actually gonna do a example of this one. Yeah, I'm not gonna do an example, but I will put this on the blackboard for you. Let's grab more. Oh, jeez, come on. This is so hard to copy a bunch of lines. Cool. Nested switch statements. All right, this is going to look something like the following. Okay. So let's say we have a switch statement and we have character 1, right? And then we just make it pretty big so you can kind of see a bunch of stuff happening. So we do, okay, case of A, right? And like, I don't know, let's just say we do system out print line. This A is part of the outer switch, okay? And then I'm gonna do another switch here, and it's gonna be based off of character 2, right? And I'll clean up the closing brace in a second, but I just want to catch up on the rest of this code here. So we can do an inner switch statement with another case that does the same thing, A, right? And in this case, we're going to say, you know, this A is part of inner switch, right? And then we're going to add our break. Okay, and then we're going to do another case here. And let's grab this. Right? And then I would basically cut off my switch here, end it. And then I also, this case, I want to add a break. Right? You know, and then you theoretically have something here like another case, right? You have case of B, and you do like dot 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 dot, right? So that's how you do nested switch statements. So you can put ifs and switches, switches and ifs, ifs and fors and switches and ifs. Any combination thereof, whatever you want. Cool. All right, we're making good time today. Probably don't got that much longer. I do want to go over for loops really quick, so let's add some more stuff to the blackboard here. All right, so let's talk about for loops. So for loop looks like this, right? You have for. And then you have your initialization, you have your condition, you have your iteration, right? And then you have a statement sequence. Cool? And that's essentially everything the for loop is, right? So we've already sort of seen this before, but your initialization is where you take some kind of a counter of some sort, and you initialize it to its starting value. Now, the declaration of that variable can exist outside of the for loop. For example, in the switch demo, we put the declaration of that integer within the initialization step itself. But I do believe, was it the guess game? Not the guess game, it was if. Oh, wait. Oh, this is interesting. Okay, check this out. Check this out. This is what the compiler does for you. So the integer here was declared outside of the for loop, right? So this is initialization for the for loop, but we've declared the variable outside of here. The compiler in the .class file was smart enough to actually consolidate it. It actually made your code better. The reason why you might want to do this is if you want to reuse that variable later on. That's perfectly reasonable. In fact, you may want the result of whatever this is counted up to be the basis for the next part of logic that you're going to act on. So you can either declare it outside or within the for loop itself. Okay, so that's the initialization part. Then you have the condition where you compare that value to something, and when it fails, the for loop exits. But as long as it's true, it succeeds. Then you do some modification to the variable to iterate, to count it upward in some way. Every time the loop runs, it runs the statement, just a bunch of code. It could be thousands of lines of code. Okay, so let's go over here to this square root example. I'm going to show you the square roots of 1 to 99. And we're going to do it really easily with a for loop, okay? So, all right. So we're going to need a for loop, and we're going to have to count from 1 to 100, 1 to 99. So and they're going to be real numbers, right? So let's do a double. Let's call it double num. And then let's initialize it, right, to 0. Or sorry, 1, right? And then we're going to say, while it's less than 100, because we're counting up to 90, we want 99 to be processed, but not 100, right? You could do 100, sure, whatever. But then we're going to increment num by 1, okay? Now, I want to take the square root of that. So we're also going to need another one here called square root, okay? I'll copy that, paste it. I'm going to say my square root is equal to, and there's a Java math library called math, okay? And it actually has a function called square root, which takes in a value like num, calculates it, and returns it. So I'm actually going to copy this, go over here, right? And I'm going to do the same thing I did before. I'm going to look it up. So let's look that up. Let's see what it is. Why did that not do what I wanted it to do? Math square root. Well, that's not the official documentation. Let's go to platform 8. We're using SDK 8 right now. You guys might be using something newer. It depends. Everybody's using something different. So let's look for square root. Check it out. Takes in a double, right? Returns a double. It returns the correctly rounded positive square root of a double value. Now, check it out. There's all kinds of crazy stuff in here. There's like trigonometric functions you can use to figure out triangle stuff. Yeah, all kinds of crazy stuff you can do here. You can round numbers. You can, yeah, all kinds of interesting math stuff. But right now we're only just going to use the square root function, right? So we're not trying to be all mathy over here. Cool. So let's print that out. Let's say the square root of num is square root. Okay? So let's run that really quick. So we're not done, but let's clear the screen. Let's compile that, and let's run it. Whoa, look at that. Look at that. Lots of values. Lots of numbers, too. So now we want to figure out what the rounding error is. Okay? So I'm looking at my example here. So square root is basically, so to get the reverse of the square root, it should take the number and you multiply it by itself, right? So essentially, what I know is that if we take the original number we worked with and we get the square root, we get the number that if you reverse the process, you'd be able to multiply it by itself and get the value. But the thing is when you do square root in a computer system, there's something called rounding error because it's a computer. And so there's some kind of rounding error that you're going to be subjected to. So if I take the original number and I subtract the calculation of the result of square root times square root, so this here reverses the square root process from math.square root, right? And it should give me num, but it won't because there's rounding error. So I want to know what the rounding error is. So I'll put a comment here. So square root times square root reverses the square root operation. Because of rounding error, it won't be the same as our original value num. Okay? So now, I'm going to say rounding error is, okay? And then I'm going to print a line. That's going to be a lot of text. So let's run that. Let's compile it. Run it. Ooh, that's a lot. Let's go all the way to the top. Rounding error. Well, let's figure that out. Let's fix that. We're going to keep it for now. Okay, no rounding error there. Now we've got rounding error of negative 4.4 to the negative 16th power. Crazy. It's a very, 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 very small amount of rounding error. But some values seem to have rounding error like, so these are actually going to be perfect. Perfect squares. These ones, not so much. So some of them do, some of them don't. Just depends on the number, right? But it's interesting stuff. Maybe not. Okay, cool. So that essentially shows you how to use a for loop to calculate a bunch of data. And again, everything that happens in here could be a heck of a lot of data, or a lot of code that does stuff on a lot of data. So, all right, now I would like to run a for loop that actually decrements a value, right? So we've kind of already, we may have actually gone over this, but we're going to run our for loop negatively. So let's start with an integer x again. So let's start x at 100, right? And let's say as long as x is greater than negative 100. Let's start adding a little bit more complexity to our map. So we're going to do x minus equals 5, right? And then we're just going to print out the value. Let's just print straight up. All right. So this is a decrement for. Let's clear the screen. Compile that. Cool. So as you can see, you can have a for loop go up in value or down in value, but it really just depends on what your definition of, of your iteration is. Are you iterating up, down, sideways? All kinds of different things you can do. Cool. All right. Let's see. What is the other example? Okay, I want to show you a for loop with commas, and what does that even mean? Okay, so the initialization section of a for loop, or even the condition section, not the condition section, sorry. I think, yeah, condition is not so much, but the iteration part, the initialization and iteration section to use commas, which allows you to do multiple things at once. So I'm going to show you two variables, I and j, and we're actually going to set I equal to 0, right? But then we're going to do a comma and say, j is equal to 10, okay? And then we're going to say I is less than j. So as long as I is less than j, we're good. But we're going to increment I, and we're going to decrement j. So they're going to technically meet in the middle, right? So I and j so that's going to print out the values of I and j as they run through this loop. So I would expect to see 0 and 10, 1 and 9, 2 and 8, 3 and 7, 4 and 6, and then it fails because 5 is not less than 5. Okay, so let's clear the screen. Let's do for loop with commas. Let's run that. Ta-da. 0 and 10, 1 and 9, 2 and 8, 3 and 7, 4 and 6. 5 and 5 does not happen. So, point to take away from this. You can have multiple variables. You can have any number. You can have any number in the iteration area here. Okay? Cool. Now, I'm going to show you a funky example. I call this the for input test. And so what we're going to do is we're going to loop this until you have pressed a specific key. Okay? So we need we're going to let this thing run forever. So this integer, you'll see in a second. There are better ways to do this, but this is just for the purposes of this demonstration. So I'm going to say you got to press the letter S to stop this code. Okay? So we're going to say I equals 0, and then we're going to leave the condition empty for a second, and we're going to say I plus plus. Okay, cool. So what I want to do is I want to print out the value of I. So I'm going to say this is the iteration or the pass number, right? But my condition, I only want it to work when the user has not pressed the letter S. So that means that every iteration of this loop, it's going to ask me to input a letter from the keyboard. So how do I do that? Well, I have to cast the value of system.in.read, and then I'm going to say, okay, that value, if it's not equal to S, do the thing. If it is, it's going to exit. Okay? So let's just try that out. I'm going to turn that off. We're almost done, so cool. So let's run this guy. What did I do wrong here? Ah, right. Gotta import Java IO. And then you gotta say that looks good. All right. That's interesting. Oh, it's because I ran the compile again. All right. Okay, press S to stop. Now press D. That's interesting. Why is it doing that? If I press Q. Huh. Why does it do that? Huh. Well, I'm not sure I want to sit here and debug something like this. But I do want you to understand that you can drive for loops with this kind of a condition here, because this is an expression. So, or sorry, it's a Boolean expression. So this is an expression, but this whole thing equates to Boolean, and so whether it's true or false. So this is allowed. I do not know why this is happening. Feel free to try to figure that out if you want to. If you figure it out, tell me. I'm not going to waste the time on it. But if you're learning this for the first time, you've never gone over this, that might be a pretty cool debugging exercise to kind of Google and figure out why that might be happening. But in any case, that's pretty much everything for today. So yeah, we'll be doing more for loops. We'll be doing some other things as well. Let me see what we got here. So yeah, I'll probably be doing some additional for loop stuff. I'll be showing you the while loop, the do while loop. I'll probably be talking about some more of how break works. But yeah, I'll see you guys on Thursday.